Oh my god, Nadia. This is just too complicated.
I know, Gigi. I have no idea how to do this project.
Yeah, I don't even know what topic to pick.
What even is Newton's second law?
I think it has something to do with apples.
I think it's force equals mc squared. Alright, let's just pick something else.
Well, do you have any other ideas?
Nah, man, I'm about as stumped as Newton's apple tree.
Yeah, I just feel like there's some sort of force causing this project to keep driving on. Some sort of resistance.
Hey, dude, I know. Let's just put on our thinking caps. Gigi, what does that say? May cause extreme drowsiness.
Oh no! Hello class. Today we're going to be learning about horizontal friction.
What is that?
I'll tell you what it is. It's the resistance of force that an object encounters when moving against one another. This fun force is a vector, meaning that it has both magnitude and direction. Thus, it is parallel to the surfaces and is independent of the force applied. There are two main types of friction, the static and the kinetic. The static friction occurs when surfaces do not slide relative to one another, and there is a lack of movement or change. Kinetic friction involves movement and action between the surfaces. Are you getting this, Chef Ranch Jessel? Okay, now on to the coefficient of friction. Does anybody know what that is?
Yeah, the coefficient of friction is the ratio between the force necessary to move one surface horizontally over another and the pressure between two surfaces.
Exactly right, and it is represented by mu. Now let's talk about the friction formula. Okay, there's originally one formula, which is the friction formula is equal to the coefficient mu multiplied by the force normal. But since they're both kinetic and static friction, it works out to be three different formulas. So the kinetic force of friction is equal to the kinetic coefficient mu multiplied by the force normal. The static friction force is less than or equal to the static coefficient of mu multiplied by the force normal, and the static friction maximum is equal to the static coefficient mu multiplied by the force normal. You getting this, Jerome? In moving a 3,700 gram box from one side of the classroom to the other, a student finds that a horizontal force of 86 newtons is required to set the box in motion, and a force of 42 newtons is required to keep the box in motion at a constant velocity. Now, part A, what is the coefficient of static friction? And part B, what is the coefficient of kinetic friction between the box and the floor? Well, first of all, we need to convert 3,700 grams into kilograms, which works out to be 3.7 kilograms. Now, based on the problem, we know that to find the coefficient of static friction, we need to make a free body diagram. And there are four forces in this case that are acting upon the box: the force gravitational, force applied, the force normal, and the force of static friction. The force gravitational is equal to mg, which is mass times g, which is 9.8 meters per second, the acceleration of gravity on Earth. So Fg is 3.1 kilograms multiplied by 9.81 meters per second squared, which Fg equals 36.297 newtons. And we can write those on the legs. And then we are given that the force applied is 86 newtons. Now, to apply Newton's second law, we will break the x and y forces into components. All the net forces of the x component forces are equal to the mass times the acceleration in x direction and vice versa. Fs is drawn to the left of the free body diagram, indicating that it is negative, so we can subtract it from our applied force. We know that Ax is 0 because the system is at rest, and we can plug in our values to find that the force of static friction is 86 newtons. In the y direction, F is drawn down of the free body diagram so we can subtract it from the force normal. Ay is 0 because, again, the object is at rest. Thus, the force normal is equal to the force gravitational and is 36.297 newtons. Now we will use the friction formula to solve for mu s, the coefficient of static friction. Okay, so the force of static friction is equal to the mu s multiplied by force normal. So mu s is equal to the force of static friction divided by force normal. And so mu s is equal to 86 newtons divided by 36.297 newtons, which gives us part A. The coefficient of static friction is 2.639. Now on to part B. Most of the free body diagram in part B remains the same, except for instead of the force of static friction in the left direction is now the force of kinetic friction, and our force applied is now 42 newtons. Now we will use the same equations as we did before, as in order to find mu k, we need to find the force of kinetic friction and the force normal. In our free body diagram, the force of kinetic friction is going to the left, so we can subtract it from the force applied. And A in the x direction is 0 because it is in constant velocity. So the force of kinetic friction is 42 newtons. Fg is also in the negative direction, so we can subtract it from force normal. And A in the y direction is 0 because the box is in constant velocity in the y direction. Thus, force normal is 36.297 newtons. Now, the kinetic force of friction is equal to mu k times force normal. So mu k is equal to the force of kinetic friction divided by force normal. So mu k is equal to 42 newtons divided by 36.297 newtons. So mu k is 1.157. And that's it for part B. Two words. Horizontal friction.
Y'all know this is Eminem. You think they're ready?
Nah, Vanessa, I don't think they're ready.
Let's talk about the force of friction. Stopping objects, no matter how persistent. Slowing them down, causing resistance. Here's an example for this instance. The coefficient of friction really grinds my gears.
Girl, I'll tell you how to find it. Listen here. Apply Newton's second law and use these formulas. They really rock.
Horizontal friction, you know what it do? This force opposes motion between two. It's really clean, yo.
Keep it low key though, Eminem.
And finessel, the real G's, bro. Horizontal friction, you know what it do? This force opposes motion between two. It's really clean, yo.
Keep it low key though, Eminem.
And finessel, the real G's, bro.
Mu is greater than mu k. It takes more force to make an object safe. Here's a little thing about horizontal motion. Success will come if you keep this notion.
Without friction, I don't know how I would stop this. Just like the cash flow into my pockets. Horizontal friction, you know what it do? This force opposes motion between two. It's really clean, yo.
Keep it low key though, Eminem.
And finessel, the real G's, bro. Horizontal friction, you know what it do? This force opposes motion between two. It's really clean, yo.
Keep it low key though, Eminem.
And finessel, the real G's, bro.
Okay, you get that? Good.
Okay, so I've got a joke for you. Two kittens are sitting on a slanted roof. They begin to slide. Which one falls off first? The one with the lowest mu.
All right.
Jerome!